and welcome to the Naked Neuroscience podcast with me, Hannah Critchlow. This month, we're switching on our pleasure zones to uncover music in the mind. We'll be finding out whether listening to Mozart as a baby in the womb increases your IQ 20 years down the line. And could we all ever achieve absolute pitch? Plus, earworms. So why are 1 in 6 people regularly infected by those annoying bits of music that go round and round in your head? This is the Naked Neuroscience podcast with me, Hannah Critchlow, brought to you in association with the Wellcome Trust and in partnership with the British Neuroscience Association. Kicking off the programme, we've had loads of questions from you on the topic of music in the brain. So to answer a few of them, I went to visit Professor Ian Cross, Director of the Centre for Music and Science at Cambridge University. To start with, Beck Hansen got in touch to ask why can she recall lyrics from a song that she hasn't heard for years, and even poetry, but she can't remember words from books. Ian thinks it's due to the structure of poetry and music.
That gives us a hook to hang the words on. We know that if the words don't match with that temporal structure, they can't be the right words. So that kind of narrows down the problem space, narrows down the search space. With lyrics to a piece of music, it's probably even more so because there's not only the rhythmic structure, but there's also a melodic structure, the tune, the ups and downs in pitch that the words accompany. Put all those together and that gives you a very powerful set of cues that help you remember. Much more powerful than just remembering random stretches of text or speech.
And Carly Pease has been in touch asking, how does perfect pitch work? And how come some people have it and others don't? Is it something that you can learn?
Well, we tend to prefer to say absolute pitch rather than perfect pitch because it's not perfect. It is absolute. That is, when you hear a note, you know it's, oh, that's an A, that's a B, whatever. Absolute pitch is something that you probably do learn, or perhaps better, unlearn. It's quite likely that in early infancy we're attuned to absolute pitch as a useful way of distinguishing events in the world. But as we develop, as we grow, it becomes less and less useful. And frequency relationship invariants, in musical intervals if you like, become more significant as ways of differentiating between events in the world than the absolute pitches at which those frequency intervals occur. However, some people do retain and develop the capacity to identify absolute pitches absolutely. Typically, if they start learning piano at age 4 or 5, there was an interesting study done a few years ago where the incidence of absolute pitch in a Japanese conservatoire and in a Greek conservatoire was compared. The incidence of absolute pitch in the Greek conservatoire was about 3%. 3% of the students had absolute pitch. In the Japanese conservatory, 57%. Why the difference? Well, the researcher looked quite closely at a number of things and suggested actually it was a question of the age at which people started learning the instruments, the likelihood that they were learning piano first, and the amount of practice that they put in, the amount of hours. The Greeks apparently seemed to be much more laid back and whatever, whereas the Japanese were, must do this, must do my 8 hours today. There was a researcher called Paul Brady who tried to learn absolute pitch, give himself absolute pitch, in his mid-40s, I think. And he eventually did learn to be able to identify pitches absolutely, but it was always effortful for him, and it was much, much slower than someone who has developed absolute pitch, quote, naturally, unquote.
Thank you, Professor Ian Cross from Cambridge University, and he'll be back again later in the show to tackle some more of your questions. And what exactly is happening in the brain when you listen to music that you like? Well, last month, published in the journal Science, Valerie Salimpour and colleagues at McGill University, Montreal, imaged the brains of volunteers whilst playing them little sound bites of music, and found that, perhaps unsurprisingly, when the participant rated that they liked a particular new tune, then a bit of their brain called the nucleus accumbens, which is buried deep in the brain, lit up with activity. It's this brain region that's involved in reward during addiction, eating nice food, and also sex. And the response of the nucleus accumbens could predict whether the people were more likely to buy a new piece of music that they hadn't heard before. But scientists think that the individual's previous exposure to different environments and different musical scenes might affect the connections to the nucleus accumbens and then drive the reward or pleasure response to the music. So we've learned a little bit about what happens when our brain reacts to music that we like. But what about earworms? So songs that you don't necessarily like. Why do particular songs get stuck in people's heads? I started by asking a few people what music plagues them.
My current earworm is Tonight's the Kind of Night, and that's by a band called Noah and the Whale. Tonight's the kind of night when everything could change. And I get this earworm when I'm driving or when I'm walking somewhere, because it's quite a good pace for walking, and I think as I'm walking, the song goes round and round in my head. Tonight's the kind of night when everything could change.
Well, I actually have a bit of a problem because there are these really cliche bits of music like Pachelbel's Canon that you hear all around the place. Whenever I hear it, for about a day afterwards, I just can't get it out of my head.
The most annoying singer currently is Rihanna. I regularly have earworms about her songs. Every once in a while you have a singer who you don't like, the tone of their voice, the content of the songs, and those are the ones that always stick with you.
To find out about the science behind this phenomena, I spoke to Dr. Lauren Stewart from Goldsmiths at the University of London, who's been collecting thousands of reports from BBC Six music listeners. I started by asking, what's the most common earworm?
That's the question that we started to ask. Lady Gaga was cropping up quite a bit, but you might well say, well, that's probably because she had a lot of airtime.
Yeah, she's being listened to a lot by the listeners, and so, of course, it's going to be going round and round and round in their head.
Exactly. So, but we were interested, are there any structural features of songs that are reported many times that distinguish those tunes? So we want to say, what are the structural features that are left over once you've accounted for recency and popularity? And we're still in the process of refining a formula, but we can say that actually many, many, many songs are reported as earworms. There's only a very small number that are reported a handful of times. So it seems that the tunes in our heads are quite idiosyncratic.
Everyone has their own individual earworm going on, yeah. I have, at the moment, I've got the Beatles' Here Comes the Sun going round and round in my head, which is lovely.
Yeah, absolutely.
Do you think there's any reason why we have these earworms?
So of all the questions that fascinates the general public in terms of music and the brain and the psychology of music, the question of why we have earworms and whether or not they have a purpose was one that, really seemed to crop up a lot, and nobody was answering it. So we thought we could try to at least have a go at doing so. And it's harder than you might think to start addressing such a question because it's a completely subjective phenomenon. All the studies that have been done on earworms have relied on people telling us, yeah, I have a tune in my head, but, that's very antithetical to how we normally measure things in science. We normally like to have something objective, some proof that there is something going on in the head, some, brain measurement or reaction time or accuracy measure, not just somebody saying, yeah, I've got, Lady Gaga Bad Romance going on in my head. Have you really? Should we trust you? How do you. But one hypothesis that I'm particularly interested in looking at is whether or not earworms are a kind of unconscious form of self-regulation. So by that I mean in the same way that when we actually choose real music to listen to from our iTunes library perhaps, we can be very deliberate and conscious about the type of music that we pick out to listen to. And it will be very context dependent. It will be very related to our current mood, the mood that we would like to be in.
Or maybe the people we're around,
what they the situation that, are we doing some boring admin at the time, or are we doing the household chores, or are we having a bath?
And do you think that people unconsciously or subconsciously pick their earworms?
Yes, that's exactly where I was going with this.
So I'm picking my Here Comes the Sun because the sun has arrived this weekend.
Well, yeah, I mean, we have published a paper looking at the various triggers that seem to precede earworms, and there are many of them. The example that you gave, Here Comes the Sun, is some kind of theme in the lyrics, has got resonance with some aspect of your environment or your life. But then there's many other triggers as well, so there could be recent exposure to a particular song. When we have an earworm, it might be that our brain is unconsciously selecting for us a tune that matches our current mood state, or, perhaps more interestingly, a tune that matches our desired state of mind.
So if you're feeling down, you may pick an earworm that's quite nice and cheery and jolly because you want to be in a good mood.
Or, for instance, I was getting ready to pick my son up from nursery, and I started getting like a nursery rhyme in my head. Now, it's difficult to say whether or not that's because I'm thinking about him, and that's something really closely related to him, or it could be, it was serving the function of getting me in a very sort of energetic state of sort of physical arousal.
Getting prepared to pick up your son and spend time with him and be, energetic.
To run around with the toddler, yes.
So you were priming your mind in some way.
Exactly. Some people say, but surely there can't be any reason for it because, I have these really uncool songs. I get like Bananarama or Mr. Blobby or, and that's surely not going to do me any good for my mood or whatever. So it just seems, so to them they think, this is really just irritating. And I think that it could be something that's specific to the tempo of these earworm songs that is serving the function of getting you to a particular energy level, if you like. Mm-hmm. From your brain's perspective, it doesn't care about what's cool and what's not cool. It would perhaps just select a tune that's in the right tempo range to get you into that state. So it's kind of complicated because it also depends on, some people might have these earworms but are less prone to noticing them. In that case, you could say, well, maybe you don't have to consciously notice them for them to do their job of regulating your energy level. So these are things that we probably have to think about and factor in as well.
So some people are possibly better at tuning out their earworm or just noticing it subconsciously.
You can see that, yeah.
Yeah.
As we have to tune out like real music sometimes if we're in public places and there's music that's distracting us from what we're actually doing. So sometimes, so perhaps that also is the case with internally generated music as well.
That was Dr. Lauren Stewart from Goldsmiths at the University of London. Back to more questions for Professor Ian Cross now. And listener Sean Hoskins got in touch to ask whether listening to Mozart could actually make you brainier. Is this a myth or has any real research been done on this?
In 1993, there was an experiment conducted that appeared as a letter to Nature. And it was an experiment where a bunch of students did a visuospatial intelligence task, then either sat in a room quietly for 15 minutes or listened to a piece of Mozart for 15 minutes, and then redid their visuospatial intelligence test. And lo and behold, the ones who were in the Mozart listening condition improved their scores by 3 percentage points, which is pretty high. So, Mozart makes you smarter. Well, actually, that study was then explored and people tried to replicate it, and some worked and some didn't. And they tried it with rats, and it seemed to work on rats. So if it worked on rats, it probably wasn't just something to do with Mozart or even music or whatever. And eventually someone worked out, well, it could be that listening to Mozart is just more interesting, more arousing than sitting in a room doing nothing for 15 minutes. And so they explored this hypothesis and got people to do either interesting things or boring things between the two versions of intelligence tests. And when they did interesting things, they got better. When they did boring things, they performed about the same. So it's not a Mozart effect, it's a boring effect. This, however, didn't stop the governor of Georgia, the US state, in the mid-1990s, issuing a governor's edict that every newborn infant in the state of Georgia would go home with a CD of Mozart. And as far as I know, this is still the case. Great for sales of CDs of Mozart, but not much scientific basis.
And they certainly haven't been doing any studies on expectant mothers and then following up their children, 20 or 30 years later.
As far as I'm aware, there hasn't been a major impact on the IQ of the state of Georgia, but who knows?
Darth Joe has been in touch via Twitter saying, are humans the only ones that appreciate music? Or what about other animals such as dolphins or other primates? Do they like music too?
Dolphins is a bit difficult. I don't know if anyone's ever asked them, really. There has been some stuff done with farm animals. A study from many years ago, as far as I can recall, explored the difference in weight gain, I think it was, in pigs when played music from Radio 1. This was in the days when Radio 1 played rock music, as opposed to Radio 2 in the days when Radio 2 played, well, pap, really. And they found that the pigs who listened to Radio 2 gained quite a lot of weight. The pigs who listened to Radio 1, however, became thin and nervous. That's probably got more to do with the noise levels and the fact that if you listen to a piece of death metal, it sounds more like an animal in pain than does Andy Williams. Although, again, that's perhaps a question of perspective. No, I'm trying to get back onto the serious track. Death metal, if you actually analyse the spectrum, it's very jagged, very noisy. It's quite characteristic of the sort of sound that in the real world would have some biological significance for a whole range of species, indicating that something was in a degree of pain or undergoing some distress or was being aggressive. All of those possible attributes would be likely to raise the arousal level, raise the stress level of the individual who's hearing this signal. Whereas Andy Williams, not much stress unless you happen to like music.
Thanks to Ian Cross. And if you've got any burning questions about your brain and the nervous system, you can just email them to neuroscience@thenakedscientists.com. You can tweet us at Naked Neuroscience, or you can post on our Facebook page, and we'll do our best to answer them for you. You're listening to the Naked Neuroscience podcast with me, Hannah Critchlow, brought to you in association with the Wellcome Trust and in partnership with the British Neuroscience Association. Next up, we paid a visit to PhD student David Weston from Cambridge University for his top neuroscience stories for the month.
I've come across a paper from a group of Spanish scientists investigating how music could be of benefit to stroke patients. So Julia Amengual and his colleagues at the Cognition and Brain Plasticity Group in Barcelona have been looking at a recently developed rehabilitation technique called music-supported therapy. And this has been designed to help stroke sufferers with their motor skills, so increasing the control of their muscles in their arms and fingers. Now, stroke is caused by starving the brain of oxygen, and it's typically the result of reduced blood flowing to the brain as a result of a blood clot. Now, the resulting brain damage can have an impact on a variety of different brain functions, from things like deficits in speech and language to your fine motor control. So following a stroke, the brain undergoes a really interesting period of reorganisation, where parts of the brain attempt to take on the functions of other lost parts of the brain, and this is often known as cortical plasticity. And previous studies have shown that considerable plasticity is required to regain fine motor control, so the ability to control your fingers following a stroke.
So is there anything that people that have had strokes can do in order to help promote this plasticity and this rehabilitation?
So that's what the authors of this paper really wanted to test. So what they did was they used this music-based rehabilitation therapy. And what they did was they got the patients to play on an electronic drum kit or to play musical phrases on a keyboard with the hand that was affected by their stroke. So when you have a stroke, your motor functions are usually affected on one side of your body. And the researchers found that the patients that underwent this music-supported therapy showed significant improvements in their motor functions, both in the range of the movements that they could make and also the quality of the movements.
And did they have to undergo quite an extensive period of this music-supported therapy? I mean, what did they have to do? Did they have to play the bongo drums or the keyboard for, hours and hours each day for a year in order to see a benefit?
This was a 10-hour stint, essentially, over that 4 weeks. So it's a relatively short period of time. And as the therapy could be quite entertaining, it seems like it's a non-strenuous way to kind of get people to really improve their motor skills. What was really interesting from this paper, though, was that the scientists found that within the brains of these stroke patients, there was increased electrical activity in the motor cortex, the bit that drives your muscles. And they found that the part of the brain involved in controlling movements was significantly reorganised as a result of this therapy.
So should all people who have had strokes, maybe strokes many years ago, or they've just recently suffered from a stroke, should they all be rushing out and doing a bit of this music-supported therapy?
Certainly these results indicate that even 6 months after a stroke, which is quite a significant period of time after the event, that this kind of therapy can be really, really helpful and reorganise the cortex in a completely beneficial fashion.
The power of music. Thank you very much, David. And my paper this month, well, it's been published in the journal Science, and it's really trying to uncover how are our personalities and our individualities shaped. Well, scientists have been interested in this for a very long time, and there's a number of ways that you can start to glean information about it. So you can look at monozygotic twins that are pretty much identical in terms of their genetic makeup, and you can look at twins that have been adopted at birth. And there are cases where there's striking similarities between those adopted monozygotic twins. They may laugh in exactly the same way or have a similar sense of humour. But then conversely, there's also cases of identical twins that have been brought up in the same environment by the same parents, and yet they've got very, very different personalities. So what's going on there?
So even though these people have got the same genetic makeup, they may turn out differently. And even if they've got the same genetic makeup, they might turn out the same. So it's very difficult to know what's causing these different behaviour traits. Is it genetics or is it environment?
Exactly, and so scientists in this study wanted to get a little bit closer to trying to understand that. So they looked at mice that were kind of from the same inbred strain, so they were genetically incredibly similar, and they put them all together in a very large cage, so 40 of these mice, that had a very rich environment, so lots of things for these mice to play with. At the same time, the researchers were able to tag each of these mice with a GPS system so they could monitor how much the mice ran around and whether they were exploring lots of different levels within this massive cage. And they collected this data over 3 months, and then after that 3-month period, they started to peer into the brains of these mice, and they looked at a particular area of the brain called the hippocampus, which is buried deep in the brain, and it's involved in learning and memory and also navigation. And they looked specifically within the hippocampus at an even smaller region called the dentate gyrus, which is one of the few areas in the brain where new brain cells are being born throughout life. And it's thought that the birth of these new brain cells is involved in how we can create new memories and also cope with novelty in our environment. And they found that the mice that were in an enriched environment that had lots of play had a higher number of nerve cells being born in this dentate gyrus. In fact, it was over twice as many new nerve cells being born within this 3-month extended period. And then they zoomed in even further and they looked at this set of 40 mice that were in the enriched environment, and there was a great degree of variation between those mice that roamed around and explored a lot, and then there were some mice that weren't that fussed about exploring. And again, they saw a correlation between the amount of new nerve cells that were being born and the amount at which these mice were roaming around. Really, the next logical question to me is, what is it about these very genetically similar mice that were kept in the same environment? Why did some explore more than others? And that's something that scientists haven't really fully got to grips with. But what the researchers are saying in this paper is that when viewed from an educational and psychological perspective, the results of this experiment suggest that an enriched environment fosters the development of individuality. And it's also maybe important to note that in humans, smaller hippocampi have been found in adults who have suffered from neglect or stress as children, and that might be related to this fewer new nerve cells that are born in the dentate gyrus of the hippocampus.
So the other paper that I'd like to discuss is something a little bit different from what we normally talk about, and it's from Oliver Sacks, the famous neurologist and the author of several popular science books, including The Man Who Mistook His Wife for a Hat. And in these books, he typically outlines some of his unusual cases as his experience as a neurologist. Recently, he's published a piece in the journal Brain where Sacks describes some visual musical hallucinations of 8 people who've contacted him regarding their unusual experiences. So these people who've contacted him suffer from a variety of different medical conditions, so from things like glaucoma to Parkinson's disease. And they describe seeing these phantom musical staves and notations, so bits of printed music essentially appearing in the world around them. In some cases, this musical notation boldly replaces text in books, or it floats around in the air and on the walls.
And were these people aware of the fact that these musical notes weren't actually there, their mind was playing tricks on them, or were they experiencing quite a scary, visual hallucination?
It seems that most of the people recognise the fact that this was unusual because they've been proactive in sort of seeking out the advice of this very famous neurologist. So it does seem that they're aware that this is very unusual behaviour, and some of their descriptions of what they're talking about certainly seems like they're almost amused or slightly, or they're very interested at least in what's happening to them.
For quite a long period afterwards, for example, when I was in the bathroom, I'd see the fake marble side and think that was electron microscopy of synapses and connections in the brain. So is it just that, you've seen something for so long that it's burnt in on your retina, and so obviously you start seeing it, you start seeing patterns in the world around you for how it's related to that?
So there does seem to be some sort of training aspect to this. So 7 of the 8 people that were outlined in this article did have a musical background. So some of them were singers, some of them had played the piano. But one of them, Christy C., reported seeing music under this high fever. So she'd see musical notation when she had a fever, when she was sick. But she describes herself as a non-musician who'd never been particularly musical. So training doesn't seem to be required for this particular type of phenomena, although I can completely empathise with what you're describing about seeing unusual things in the world around you, having spent a long time doing something. In a much more lowbrow example, when you play the video game Tetris, for example, for a really long period of time, you might find that when you look away, you can see the blocks arranging themselves in front of you. And it seems to be that your brain adapts and gets used to a particular visual sensation and then appears to try and replicate this into a blank wall or space.
You're speaking from personal experience with repeated exposure to Tetris there, David?
Maybe.
Thanks, David Weston. And if you want to find out more about any of these stories, the references are all on our website. That's thenakedscientists.com/neuroscience. And closing this month's show, we cast our ears over to the States to find out what gets Dr. Phil Corlett from Yale University leaping out of his bed, switching the radio on and looking forwards to his day in the lab.
Hi, I'm a cognitive neuroscientist, and I'm fascinated by the tricks that the brain pulls to help it deal with all of the information coming in from the world. Tricks that we can see in action when we observe optical illusions like the rotating hollow mask. The face on the mask uncannily always seems to point outwards because, in our experience, faces point out. This illusion underlines how our expectations and our beliefs sculpt how we see the world. Sometimes these tricks fail, and when they do, people perceive the world in a very different way. I'm talking here about patients with psychotic illnesses like schizophrenia. These patients seem less able to use their past experiences to appropriately constrain what's happening to them currently. A little bit of this can help with creativity, but too much can lead to experiences and beliefs, what we call hallucinations and delusions, that aren't shared by other people and that are bizarre, intrusive and distressing. For example, sometimes patients' brains might predict sounds when there aren't any, manifest as auditory hallucinations. Other times, their brains might fail to use predictions to screen out the things that the rest of the world would ignore, imbuing those things with a meaning and a significance that patients form delusions in order to explain. I recently received the International Mental Health Research Organization Rising Star Award. This organization funds new research into the causes, treatments and prevention of mental illness, and the award will help fund a pilot project on the role of potassium channels in how predictions are specified in the brain. Nerve cell membrane excitability is one mechanism through which predictions might be instantiated in the brain, and we think that potassium channels might regulate that excitability. We're going to try to find out whether altering potassium channel function in the brain using a drug called retigabine might help patients with psychosis make better, more veridical predictions about their world. We hope that this work will inspire new treatments for psychotic illness, treatments that are grounded in cognitive neuroscience. I'm a neuroscientist because I'm interested in how the brain forms beliefs, what happens when that belief formation mechanism goes awry, and what we might do to try to help.
That was Dr. Phil Corlett explaining his intrigue with the fine line between creativity and delusions. I'll be back again next month to uncover addiction. Are there genes that predispose you to addiction in later life? Can you wipe memories to help addicts walk past a pub a little bit easier? And why drug taking is so risky in the younger brain? You've been listening to the Naked Neuroscience podcast with me, Hannah Critchlow, and in association with the Wellcome Trust and in partnership with the British Neuroscience Association. See you next month to open our minds. Bye-bye.